Why do some chargers tend to charge some phones fast and still charge other phones slow? So to start with, you need to understand how charging works. When you look at your charger, you're going to see numbers like voltage and amperes, or V and A. If you look at your charging output, you likely see 5 volts, 2 amperes, 10 volts, 3 amperes. That's how you know what your phone outputs and how fast you can charge your phone. So to explain further, you need to consider things like charging technology or protocol, the charging configuration of the charger and your phone, whether they actually match. Let's talk about charging protocols. In phone charging, we have protocols like PD 3.0, which is the most popular one that every brand is switching to now. So PD 3.0 is actually all about controlling charge that's going to the phone. The protocol helps your charger and your phone to communicate. Let me give you an example. If you have a charger that supports PD 3.0 and a phone that does not support PD 3.0, you still will not get fast charging. Or you have a phone that supports PD 3.0 and your charger does not support PD 3.0, they will not be able to communicate properly. So you might get fast charging, you might not get fast charging. So what is PD 3.0 all about? Like I said, if you look at a phone charger, you're going to see multiple configurations of charging that it supports. Most of them will have 5 volts, 2 amperes, that's 5V, 2A, 10V, 3A, 10V, 5A, and so on. So if you buy a phone, you actually will have ports for multiple charging configurations as well. Most phones will support 10 watts, 25 watts, 120 watts, 33 watts, depending on the configuration. Let's take this phone for example. This phone supports 10, 15, and 45. So what charging protocols do for you, both PD 3.0 and PPA, is that when you connect your charger to your phone, both the phone and the charger will communicate. So modern chargers are not just passing current anymore. They actually have processors inbuilt inside them to communicate with your phone. So your charger basically will tell your phone, I can supply 15 watts, 20 watts, 25 watts, and your phone will say, okay, give me 25 watts. And the charger supplies 25 watts to your phone, and your phone now charges at 25 watts. So let's say you get a phone that does not have the proper protocols, and you take a fast charger and plug in. The charger will tell the phone, see, I have 15 watts, 25 watts, which one will you like? And the phone will not say anything. The charger will simply just supply whatever it has to supply, and your phone might actually charge fast or charge slow, and you will complain, but it's nobody's fault. Another thing there is, you can buy a 45 watt charger for example, and that 45 watt charger actually supports 5 volts, or let's say supports 15 volts, 3 amperes, that's 45 watts. But your phone maybe supports 20 volts, 2.5 amperes or whatever. Your phone, both of them are still 45 watts, but the configuration is not the same. So the charger will say 45 watts, your phone says 45 watts, you plug it in, you still don't get 45 watt charging. Maybe both of them will now step down to 15 watts. Maybe your charger also supports 15 and your phone also has 15, and your phone will be charging slow on a charger that can charge fast, simply because the configuration of your phone and the charger are not the same. Which is why it's best to always use your follow-come charger to charge your phones. With newer technology, chargers, they even go beyond supplying fixed voltages like 9 volts, 3 amperes, and they can actually program or reprogram the current, as the circuit, to give out a particular voltage or current like 6.3, 6.4, depending on the charging needs of the device that is receiving the current or receiving the charging. This is why your phone, you can use a 120 watt charger of today to charge AirPod that only needs like 5 watts, and the AirPod does not overheat because the phone actually steps it down to that 5 watts to charge your AirPod. You plug it to your phone is 45 watts, the charger steps it down to 45 watts to charge the phone. You plug your laptop is 80 watts. The charger steps it up to 80 watts to charge the laptop. So one charger serving multiple purposes simply because of these charging protocols that helps chargers communicate with devices that you are charging. Another thing that can make your fast charging charger not charge your phone fast is your cable. Some people know, others don't. Some people think the cable or the cord you are using to charge your phone does not have anything to contribute, but it actually does. Some cables are only capable of 3 amperes, some other cables are rated at 5 amperes. And you can even have bigger charging cables that are rated at higher capacities. So let's take this example. You're using a phone that's 45 watt charging, but it takes 9 volts and 5 amperes to charge at 45 watts. Your charger also does 9 volts and 5 amperes to supply the 45 watts. But then you buy a cord that only has some support for 3 amperes. You're going to use this cord to connect your phone. And because it only supports 3 amperes, there is no way it's going to allow 9 volts and 5 amperes to pass through it. So your charger will end up settling down for 15 volts and 3 amperes to charge your device, or it will still supply the full current, but the cord will not be able to supply this current is receiving to your phone, which means your phone will still end up charging slower and maybe even heating up because it's not receiving the current it should be receiving. In the same manner, this same cord that could not charge your phone fast, if you plug it in another charger that supports the same 45-watt charging as the old charger you're using, but this time around this new charger actually supports 15 watts and 3 amperes, and your phone also supports 15 watts and 3 amperes, and you plug in this cable that is only rated at 3 amperes, it's still going to charge your phone at full capacity. So your phone is going to charge faster at 45 watts, even though this same charger or this same cord on the old charger could not give you the same thing. It's still giving you that same 45 watts on a new charger simply because this one actually supports that configuration that the cable also supports. So the last thing that affects your charging speed is efficiency. When electricity is passing through your charger, your cable, even your phone, there must be a drop in current. It's going to lose some of the power that is coming from the charger because of inefficiencies. Your cord is going to resist the current, your phone is going to resist the current. So all those heat, the heat your phone produces when it's charging, your charger heating up, usually means you are losing some energy on the way. So let's imagine you buy a charger, it supports 5 amperes. Your phone supports 5 amperes, your charger supports 5 amperes, but the cord itself that you are using, why it supports 5 amperes is not very efficient. If your charger supplies 5 amperes to the phone, let's say 15 volts and 5 amperes, it's going to lose some of it, some of the energies already supplied inside the cord itself, the cord that is charging your phone. So your phone will end up receiving less than the charger was sending. So your phone is going to charge slower simply because the cord you are using is not efficient enough at passing the current that is receiving. So these are factors that you actually should consider before you buy a new charger, a new cord, or even a new phone. Instead of just going to the shop and taking any charger they give you because they say it's fast charging, read the description, look at the outputs, compare it to what your phone actually supports. Look at that cable, is it 3A or 5A? If you check all these things, then you can be certain that this charger can charge your phone this fast, instead of just guessing or maybe taking it home to test it out and then you complain and say they have sold you a fake charger or something because it says 45 watts but you cannot charge your phone 45 watts. It's simply because it takes more than that. Like I already explained, you have to factor in the voltage, the wattage, and even the cord you are using and other things. There are even more factors to consider, but these are the major ones that will actually determine whether your phone will charge fast with a fast charger or not. Some people will take a phone that only supports 10 watts and then plug it in a charger that supports 120 watts and they expect that phone to charge fast. It's not magic. If you like, take laptop charger and plug into your phone and expect it to charge fast. It's not going to charge fast because it does not support whatever that charger is supplying. So it's still going to take that 10 watt that it supports and charge the phone, which means even with the fastest charger in the world, as long as you have a slow charging phone, your phone is going to charge slow. Even with the fastest charging phone in the world, as long as you have a slow charging charger, your phone is still going to charge slow. It's not magic. You have to look at the numbers. In this video, I'm talking about fast charging. Does fast charging actually kill your battery or not? Subscribe to watch the next video that I'll be talking about that.